Okay, so yeah, I'll try to be quick really because this is in fact a sort of high level presentation and then I'll try to make some room for lunch for you guys or otherwise for questions. It depends on how it goes. Anyway, my name is Vitaly Wool, working for a Swedish branch of the Linux consultancy company called Consulco. So there's Consulco AB. And I'm going to be talking a little bit on mostly on the descriptive level of the problems and solutions that we had to make during implementing secure boot for several devices running AOSP flavor, and why we chose or why we were happy with U-boot as a bootloader for those devices as opposed to the other bootloaders that are more common in the Android world, especially for those who are working with mobile devices running Android. Okay, so as I said, I seem to have a long Linux background, maybe somewhat boring, but however, I was working with embedded Linux since 2003 back in the Mona Vista days, so that was the company in the US pioneering in productizing embedded Linux and doing embedded Linux for money, basically. So then some 10 plus years ago, I did move to Sweden and has been living in Sweden ever since. So I'm doing various Android, AOSP, and other embedded Linux tweaks within Consulco, working both for Swedish companies as a consultant and for American ones. And I try to be present in the main line as much as I can. I am one of Z-Swap maintainers, and yeah, as a matter of fact, there was a group effort of us posting execute and play support for RISC-V. It's been a while ago. I don't know how it feels with XIP there right now. Haven't checked for a while, but we have some plans to return to this and do some advancements. So anyway, going from me to the outline for this presentation, we'll just touch base on the embedded distributions because they sort of fall into three groups: Yocto-based, AOSP-based, or strange stuff-based. We'll just run through the Linux secure boot for ARM and how it's implemented, how it's supposed to work, and what are things that are specific to Android when it comes to secure boot and verified boot. And we'll take the NXP implementation of secure boot because it uses U-boot. And I'm not promoting NXP. I'm not going to be paid by NXP for this presentation, but they do have some advantages compared to other vendors. And then we'll jump to conclusions. So let's go. When it comes to embedded Linux distributions, open source software embedded Linux distributions, well, first and foremost, people think about the Yocto project, which, however, outlines itself as not a distribution but a means to create one. But still, whatever you make out of it, if you really follow the rules, if you really follow the guidelines, whatever distribution you will make out of what Yocto project has to offer, they will be very, very much alike. So we can still see this as a family or as a single distribution because there are some bigger differences between different versions of Fedora, then differences between different flavors of Yocto. So we'll still think of it as of a distribution, and it's community driven, and it's like full open source, whatever. And then there's AOSP. There's quite a bunch of open source embedded Linux distributions using Android one way or another. And as opposed to the Yocto project, it's mostly led by Google, even though there are contributions from various developers who stumble upon something. And then again, there's such thing as OpenWRT. We cannot really disregard it. It's also a distribution. I haven't really heard of any real consumer electronic projects, or well, especially things related to security that actually use OpenWRT. But maybe there are some. However, we will be mostly comparing Yocto and Android, and OpenWRT I'm just mentioning. Then there are some things that we mark as homegrown, mostly Buildroot based or whatever, and I don't mind that. Sometimes it's a very good solution, maybe an interim solution, but still. However, again, we will not be concentrating and comparing it that much because in terms of security, Buildroot will be either following the Yocto footsteps or not doing much of a security anyway. And then there are some marginal things that, always seem to happen when the community is fragmented, but well, it's up to the people that do those marginal things. Will not be concentrating on that at all. Okay, Yocto. It uses Open Embedded as a build system that's that has its good and bad things. Well, I'm not a huge fan of Python myself. But that's a whole different story. Anyway, it's a Python-based build system. We absolutely must admit that it produces small and neat images, highly customizable. Well, yes, it is nearly incomprehensible. Well, that's my personal opinion. I have some hacks behind that, but some people think it's just awesome. Well, I don't know. There are attempts to rewrite the bitbake in Rust, which will probably make it even more incomprehensible, but slightly faster. Yocto, well, it does require a lot of fine-tuning, which also, well, it's a good thing, it's a bad thing, and then what we can say is that application development, I mean, we can configure an awesome Yocto system, but then again, the user wants to have applications that are nice and easy to use, and development of those applications, well, it's not that simple. As opposed to AOSP, I have a lot of bullets here, but the main advantage of AOSP and why people tend to go for that option for devices that are, well, quite far away from mobile phones and tablets, like, I don't know, washing machines. There are washing machines running Android. So it's rich in applications. It doesn't require a lot of fine-tuning. And it's easy to develop new applications because, the whole infrastructure is there. Well, speaking, bullet by bullet, if we compare it to Yocto, it produces a lot bigger images than Yocto, so it might not be possible to use it for some particular applications, but However, for most, it's still okay. It's also nearly incomprehensible, but the good thing, or not the good thing, or well, the good thing about this for AOSP is that you might not really be required to comprehend. Okay, so you can still you can be like somewhat ignorant about how this whole thing builds and works, and still be able to produce a device based on that. It's not going to work for Yocto. It can, with some limitations, work for AOSP, and this is the thing that also draws attention to AOSP and makes people choose it over Yocto, and that's a valid point, because for some applications you just don't need to rebuild most of the stuff. You can just develop applications in Gradle and be happy. So we smoothly transition to reasons to choose AOSP. We have started talking about it already. So it's the time to market because, well, applications are easy to develop, or there are already many applications available. Some of those are open source, so you can just take those, modify a little bit, go run it. Hardware graphics support. It's yeah, you get that one. You mostly get out of the box for most of the modern platforms, and that's also nice. It's not really that easy for Yocto, where you still have to fight for a working graphic acceleration for Wayland. Yeah, well, we're not gonna dive into this, but still, it's a valid point. Hardware graphics support and the GUI, which we all know, and maybe it's good, maybe it's not that good, but it has become intuitive because many people use Android phones. So the Android GUI has become intuitive because people got used to it. And finally, well, valid or not, there's a reason to choose AOSP called it's secure, because Google advertises verified boot. Yeah, we'll touch base upon what that is. So it advertises Android AOSP as a secure system. Okay. Anyway, just another recap, more or less. Secure boot on ARM or ARM64. Well, we're mostly dealing with 64 right now. Is based on the trust zone, which creates an isolated secure world with trusted OS and possibly applications. So the whole thing forms trusted execution environment, which is executed in a secure area of the main processor, and either the RAM is the part that is also secured and not accessible by the outside world, or some designs like, well, NXP use a separate RAM chip, which is like SRAM, to provide RAM for the trusted execution environment. So that's inside, and outside is the rich execution environment, so-called, where you have normal operating system, like, well, Linux in our case. This is a Linux conference, right? And then there has to be some kind of interface to communicate with the trusted execution environment, so some kind of API, some kind of messaging interface, whatever. And this is how we get answers from the T, if we want some answers from T, while running the rich operating system. So yeah, the picture is taken from the ARM manual. Not probably not very interesting to anyone, but still I wanted to have it in the presentation just for reference. Okay, so when we go to the Yocto ARM combo secure boot, um, the uh, the weapon of choice is U-boot, the very common bootloader in embedded Linux world. So it has the part which called SPL, the smaller U-boot, and then there's main U-boot, and even though you can do it in many ways, usually SPL runs in trusted environment, and then it verifies and loads the main U-boot, which is running in the outside world, and then it's also not an absolute must. As we know, Yocto is very configurable. It's not an absolute must, but um, it's like 99.9. You're gonna have opt as trusted OS, and there's the client which runs in the non-secure world and provides the interface to the system which runs in trusted environment. And then again, there's Yocto Linux running as rich OS, but it's no surprise. Android. Well, if we look into the Google documentation, then there's not that much about secure boot itself. They don't seem to advertise what they're doing to provide secure boot, and that's probably because they are not doing that much, and it's mostly left up to vendors. But Android does have a verified boot, and there we have a picture, and they do claim it's a very nice thing, and in fact it well, it is. But the problem is that it's not quite clear for many how this verified boot relates to the secure boot. Is it the same thing or the same thing? Well, they are not the same, and in fact, secure boot is the underlying mechanism that allows verified boot to work reliably. So secure boot is the enabler for verified boot. But another thing is that these underlying mechanisms that enable verified boot, which is like the same and standardized for Android devices. The underlying mechanisms are not standardized and maybe very fragmented, well, as much as the whole thing with ARM Trust Zone and trusted applications allows it. For instance, if we take a look at a typical vendor secure boot stack for Android, I guess many of you could have seen this picture because it's a big vendor. There's the bootloader, or as it's called, extensible bootloader. There's also primary bootloader, which is in the very beginning, the leftmost blue rectangle. But that's pretty much in ROM. We don't have any power to change it. Then there's the secure part of the extensible bootloader and the non-secure part, and this somewhat maps to SBL and U-boot in the Yocto case. But then comes hypervisor extension environment, which is something different. And then there's another bootloader, which can be whatever. And that one loads the kernel, and this method seems to be more complicated than the one that is used in Yocto, and in fact, it's complicated for no specific reason, just as I understand, just for the sake of reusing the old code as much as possible. So this is why they need this old bootloader, which is called OS bootloader, because otherwise I don't think it's really necessary to have it anyway. So what we have for a typical vendor software implementing secure boot is that we have a lot of custom proprietary code that is verified to work only on a certain platform, the one that the delivery is made for. And this is okay if we use this platform directly, if we don't change it. But if we as a customer or our customer uh, for us as a consultancy company wants to have something deviating from this reference design, this may become troublesome. So if we spin off our own hardware, it may become troublesome because we are pretty much out in the unknown. And then there's usually some lacking documentation, and the only thing that you can do is to turn yourself to the support for the vendor that you chose. And well, I guess many of you in this room had some problems talking to support engineers for various vendors. Once again, no finger pointing, but sometimes it doesn't go as planned. And here's where U-boot comes into play. I mean, as we can see, there's still quite a good mapping between the Yocto U-boot way and the Android and XBL way. So what if we just try to take U-boot and put it there instead? And because U-boot, well, not being ideal in any way, still has significant advantages like strong community support, good documentation, coding standard more or less being followed. I haven't talked about the vendor code. I was talking about I was talking about vendor code on various conferences like many years. I have given up on this topic. I think I've said everything I wanted to say. So that it's an open source software. It has a community support and it's documented. And if you step aside, if you step to the left or to the right from the normal path that the vendor paid for you, if you do it with U-boot, it's likely that the issues will be traceable and you'll be able to either resolve them yourself or with the help of community. If you do it with the vendor software, well, once again, let's call the support. There is a set of platforms. There are several families. And these are IMX platforms from NXP Freescale. And they do use U-boot for Android, for AOSP. So we take those as an example. This can be well extended for many other platforms for manufacturers, but we take this specifically for the projects that we've been working on that are relevant to this subject. It was IMX8, several flavors of IMX8. And what they claim, is that they have best from the two worlds by using U-boot for Android. So they're using so-called security enhanced U-boot for Android, which has Android verified boot support. It has fast boot support. It has fast boot OEM commands for setting hardware keys for to enable cryptography and keymaster and whatnot from the insecure world into the secure world. And they have U-boot has fuse command to program eFuses. So it's still open source. The U-boot that comes from NXP is still open source. They have their own Git tree, so it's easily extensible. Most of the stuff that they have developed, they have also upstreamed. So they're not deviating that much from the real community version from vanilla, which is also a good thing. Um, on the other hand, they do not exactly follow the Yocto footsteps, if we may say so. They're not using Opti for Android AOSP solutions, so they use it for the like pure Linux stuff, but not for AOSP. Instead, they use the thing called Trusty OS, which is basically developed by Google, and they have a downstream branch of that. The not so nice thing is that it's provided by NXP as a binary, and unless you actually dive into this and learn that it's not a closed source thing, you actually can get the source code, and you can rebuild it, and you can modify it in the way you want. If you don't know that and just use the binary provided within the NXP tree, well, you may spend a lot of time debugging things that you could have just avoided. There is a rationale. There is a rationale for NXP to choose Trusty OS over Opti for Android. Even though I do know about some attempts to have Android running Opti client and system, but I don't know of any production devices running that combo, because Trusty OS, well, it's more tailored for AOSP, and it has good support for things like this Keymaster 3 thing, within Android, so that you get really secure key handling in the rich system. And Opti, well, doesn't support it that well. And once again, Trusty OS is still open source, so we don't make a compromise, at least on that part. So yeah, Trusty OS is integrated in the whole picture of Android running in a real secure environment, and this is why it is still preferential to use it. It's a good choice. However, well, best from the two worlds, maybe. There was a question, maybe out of the box. Well, no. Once again, if you deviate in your designs, or if your customer deviate in its design of the hardware, then you may run into severe problems. Like, for instance, if you don't have USB available, how are you gonna flash the keys that you're supposed to flash with? By using fastboot commands. So we can use fastboot over Ethernet. Well, what if the device doesn't have Ethernet as well? What if it only has a Wi-Fi? Yeah, running fastboot or Wi-Fi in U-boot is probably not that good of an idea, but we can extend. Well, since we have fastboot support, it's a very nicely written thing in U-boot. Simple, so we can just add serial connection and have it done. Another project that we had a requirement to boot from the SD card for the first time, and that SD card should contain everything, like make the system secure and bootable and whatnot. And we discovered that on their platform, and I think it applies to most platforms. Depends on the SD controller, but usually it is true that Trusty OS just doesn't work off of CD card. So that one should be disabled specifically for the boot from the SD, but then you have to have another U-boot which has Trusty OS enabled to be flashed on the eMMC, and and then you get the full configuration. The good thing is that, well, with U-boot, it's easy to configure and build, and it's just builds within one and the same build. You can build for several configurations. So once again, you just, at the end of the day, you press a button or enable it in Jenkins, the build in Jenkins. So it's a one-off effort, and that speaks for U-boot's advantage as well. Well, out of the box. Now, another thing is that once again, if you deviate in design of hardware, trusty OS binary provided by NXP will also not work most of the times. Because, for instance, it has debug capabilities enabled, and debugging information is written directly to a UART. And if you don't have that UART in your system, or if you keep it disabled for some reason, then trusty OS will silently crash. Trying to put debug messages to the UART, that is not existent. And now imagine the problems that you might have had if you don't have the sources. But luckily we do have the sources, so we can debug things like that. And as a matter of fact, what's also nice with this, having the sources thing, is that at the end of the day, we might want to just switch off debug completely, because it doesn't make any sense to have trusty OS putting debugging messages in a production system. I mean, it should just work, right? Otherwise, it's not trusty. Okay, jumping to conclusions. There is no silver bullet. Yeah, there's no ready solution, as always. But there are several advantages of using U-boot for AOSP project, both generally speaking and taking into account security considerations, because it's more maintainable, and generally speaking, and it works well security-wise. And then we took the example of NXP, because they have things in place which are mostly reasonable. So they use U-boot, they use trusty OS, which is a good choice of secure OS for Android. However, once again, there's no silver bullet. You should be prepared to customize and rebuild stuff. But then again, once we get into the open source, this is easier. So open source software rocks, because we can do things ourselves. We can fix things. We can debug things, customize. So we are getting closer to getting a silver bullet, on our own. And I guess that's all. Let's finish on this optimistic note. Thanks for your attention. And we still have some time for questions, if any. Most of the stuff comes from a project where there was a how should I put it? It's a system that controls workers. So people who go for construction work. So people enter the object, and then there's this system which verifies that they have the rights to access the construction works. That there are also some sensors and telemetry that makes sure that people are fit to work this particular day. and so on. And so it's access slash health control for construction workers, basically. Yeah. For instance, it's a U.S. project, so they have very strict rules about not leaking the medical information. So if it happens, then the whole thing, the whole company is screwed, more or less. So they were very on their toes about this one. Thank you.